Hi, we're going to go over the square root expression. So this is your lesson on the square root function. To begin with, we're going to remember how to simplify a square root. So when we're simplifying a square root like the square root of 324, we're going to use the prime factorization of the radicand. Now the radicand, remember, is what is underneath the radical. That's the radicand. So we simplify square root of 324. If we did a factor tree, this would be 2 times 162, and 162 is 2 times 81. 81 is 9 times 9, and then 3 times 3, and 3 times 3. So now you notice I have 2 2's, which are right there, and then I have 4 3's, and those are right underneath there. So after we've done that, we can apply the property of square roots. So when you have 2 2's, that's the same as 2 squared. And then the same thing goes for the 3's. 2 pairs of 3's are 3 squared and 3 squared. Now we know the square root of a square number is just that number. So the square root of 2 squared is 2, times the square root of 3 squared, 3, times the square root of 3 squared, 3. And then in order to get our answer, we do 2 times 3 times 3, and so we have 18. That's the simplified version. Now, so if we have the same thing applies even if the radicand, or the number underneath the radical sign, is a fraction. We do the same thing, except we're going to do the top part, and then we're going to do the bottom part, and then simplify from there. So we're going to factor. So this kind of walks through. Prime factorization of 25 is 5 times 5. So we could write that there, 5 times 5. Now 441, that's a little bit trickier, but it can still be factored. One little trick that I like is if the digits of a number add up to equal a number that is divisible by 3, so 4 plus 4 plus 1 equals 9. If this number is divisible by 3, then that is divisible by 3. So then I can use my calculator, and I know that 441 divided by 3 is 147. And the same thing, 147 divided by 3 is 49. Now 49 is 7 times 7. So the prime factorization of 441 is 3 times 3 times 7 times 7, because we have 2 3's and 2 7's. Now in its simplest form, so we can rewrite this as the square root of 5 times 5 over 3 times 3 times 7 times 7. Now one thing that I like to remember is for every pair underneath the radical, one of them comes out. So if I have 5 times 5, then I have a 5 come out. Now I still have my fraction sign here. I have a pair of 3's and I have a pair of 7's. So 1 3 and 1 7 comes out. And so then our final answer is 5 over 21 is the simplest form of that. Okay, let's look at one with a variable and a constant. So we've got the square root of 4x to the 8th. So we're going to do the same thing. We're going to factor. 4 is 2 times 2, and then x to the 8th is x, 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 x. Is that 8? 1, 2, 3, 4, 5, 6, 7, 8. Okay, now to simplify this, we're going to do our same process. We're going to take for every pair, 1 comes out. So we have a 2, and I have 1, 2, 3, 4 pairs of x's. So that would be x to the 4th. Now the same thing applies. What if we have a number or a radical like this, the square root of 8y to the 5th? We do the same thing. We factor 8, so this is the same thing as 2 times 2 times 2, because remember 8 is 2 times 4, and that's 2 times 2, so I actually have 1, 2, 3 2's, and then I have 5 y's. So the same principle applies. For every pair underneath, 1 comes out. So I've got 1 2. Now this 2 has to stay underneath the radical. And then I've got 1 two pairs of y's, so that's going to be y squared, and I still have a y. So then we still have, underneath the radical, we will still have a 2y, and that is this one's simplest form. Now, when we're comparing the square root function to a transformed function, we're going to be looking at graphs and what that means. So if we have a graph here, and we're going to graph the square root of x. So I'm going to make a little t-chart here. So if x and f of x, for f of x equals the square root of x. So if x equals 0, f of x equals 0. If x equals 1, f of x equals 1. If x equals 4, f of x equals 2, because that's the square root. So now if I go into graph these points, and I'm just going to kind of 0, 0, 1, 1, 4, 2, and that is roughly the square root function. Now we're going to be reflecting them across the x-axis, or excuse me, this one's the y-axis, but whenever you reflect it, so across the y-axis, this point stays the same, and it's going to be exactly opposite. So instead of 1, 1, it's negative 1, 1, and then negative 4, 2. So it's like we set a mirror up right here, and we reflect it across the x-axis. So we could make a t-chart for this. If g of x equals the square root of negative x, and I'll explain this in just a second. But if x is 0, g of x is going to be 0, x is 1, g of x is going to be 1, and x is 4, negative 1, g of x is going to be a positive 2. Now the reason, usually we say, well, you can't take the square root of negative numbers. You can't. But if you have a negative of a negative, that makes it a positive. That's why if we put a negative 1 in for x, negative times 1 times negative 1 equals a positive 1. And the negative, or the opposite, of a negative 4 equals a positive 4, and the positive square root of positive 4 is 2. So when we're looking at this, the domains are the x values, and the ranges are the y values. Now this one is just asking for the domains. So let's look at this. Are the domains of f and g the same? Are the x values the same in these two graphs? No, they're not. One is positives and one is negatives. The domains of f and g are both real numbers. Well, in this case, again, one is only positive and one is only negative. So that's not right. The domain of f is x is greater than or equal to 0. So f is this function. Are our x values positive, greater than or equal to 0? Yes, that checks out. And the domain of g is less than or equal to 0. Are these numbers less than or equal to 0? Yes, that checks out. So this one is correct. And then if you look at this one just has it backward, where f would be the negative and g would be the positive.